figured out. So first of all, Tom, what did you guys figure out? You were talking a lot.
That's on.
It's 1 equals 1?
Oh, well.
Okay, front group, what did you guys think?
Approaches 1.
Approaches 1. So like converges to 1. Okay. I will say instead maybe converges to 1.
Yeah.
Corey, what did you guys think it was?
Well, I thought it was -1/2, but I'm wrong.
Okay. Well, I didn't say you were right or wrong. I was just curious what you did.
Oh, no,
I said it was positive.
Okay, so the -1/2. Okay, then we have positive 1/2 over here, and we have positive 1 in the back and in the front. Question, this side, we talked about yesterday, if you look at adding all these up, what happens to the insides? They all cancel. So what's going to be left?
I didn't say that.
Whoever your B sub 1 is,
N plus 1.
y n plus 1.
Because you're very fine with your term.
Isn't this one n equals 1? You have this guy and that guy?
Yes.
N equals 2, you have that guy equals 3? So you would have your b to the n plus b to the n plus 1 whenever you stop it. So this one would cancel from previous. This one, which would be 1 higher than where you started, technically should be a minus 1, would be left. So whenever you end this infinite series, because remember we can't get to infinity, we can only approach. So whenever we end it, for the 5th partial sum, the 10th partial sum, the 100th partial sum, the last term would be, for instance, the 100th partial sum, would be the 100th term plus the 101st term. So you'd end up with the first minus the last. Okay. A telescoping series will converge if and only if what?
B approaches a finite number as approaches infinity.
B sub n approaches a finite number as n approaches infinity. Now, B sub n, in context of the one up here, is a little bit different. In that B sub n, what I'm technically talking about is, and maybe we should change this just a little bit, what I'm technically talking about is A sub n. I want to divorce it just a little bit from this idea up here, separate it. Because this one is saying, hey, for the first term you have B1 minus B2. For the second term you have B2 minus B3. So you have your n equals 1 term, n equals 2 terms, n equals 3 terms. And in your nth term, part of it cancels, part of it stays. So when you think about what part would stay, and is that part approaching a finite number? So in the one up above, it would have been only if the B sub n plus 1 approaches a finite numbers and approaches infinity. So it depends on the problem as to which one we're talking about. But in the one up above, what stays is the B sub n plus 1. In this example up above. Which is why we say, okay, the sum of the infinite series, since it, or if it does converge, will be B sub 1 minus the limit as n goes to infinity of that remaining piece. So in this one over here, right? And this one over here, you guys see how the 1/2 are going to cancel? And the 1/3 are going to cancel?
Yep.
And the 1/4 are going to cancel? Let's go ahead and stop it. Okay? Plus, dot, 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 plus. Don't we have the 1 over n minus 1 over n plus 1? Okay. So what part's going to cancel and what part's going to stay? That's going to cancel, right? Because it's going to cancel with the previous. What's going to stay? The 1 over n plus 1. So if this converges, let's test it. It would equal 1 minus the limit as n goes to infinity of 1 over n plus 1, which equals what?
1.
So we can say the sum is 1. When else do we answer not only with convergent or divergent, but if it is convergent, with an answer to the sum? Geometric series when R is So now we have one other time that we can say what the sum is. We can say what the sum is when dealing with geometric series when R is in between -1 and 1, or if we can find a telescoping series. Tom?
Why is what does it mean
Well, what Jason was trying to say, or no, I think this was you saying it, is that technically we can't get to infinity. So he's saying, well, it doesn't equal 1, like it converges, it stabilizes, gets closer and closer and closer. So that's what he's trying to say, but technically, they're gonna ask us to evaluate, and so we would just answer 1. Does that make sense? Okay. So ready, set? You guys have the idea, right?
Yes.
Go!
So we accept the.
Find the sum. Well, they can only be asking us this if A, it's geometric. Is it?
Oh, wait, you can split that.
Give them time to think.
Taking away everyone's education.
Pause. Back to what I was saying. They said find the sum. Like on the quiz from a couple days ago when it said evaluate. At that time, you hadn't learned telescoping, so they must have, or it must have been, geometric. Now, it's like, oh, it's either geometric or telescoping. Is it geometric? How can you tell just by looking at the nth term? You need, not n squared, that's p series. Yeah, to the n power, 2 to the n, 3 to the n, whatever. So nothing's being raised to the n power, it's not geometric. Telescoping. Expand it.
Partial fraction.
Okay, we'll just do 2. Oh, that's what she's supposed to do.
Oh yeah, I can totally tell, they're all canceling out, right?
No.
Not as written. So why did I shush Noah up? Some of you already figured when he started to say split it up. Partial fractions. Banana with almond butter.
Almond butter is great.
Probably peanut butter tomorrow though. I think almond butter is almost fun.
That one's so good.
I didn't get stirred at the very, very bottom. I tried. Remind me of the shortcut.
Cover.
Corey, focus. Remind me of the shortcut.
Cover.
Cover what?
Thing.
Plug in what?
0. 2.
I'm covering up n, so I plug in 0. 0 minus 2 is negative 2. 2 over negative 2 is?
-1.
Oh dear, I heard so many wrong answers first. Pause. Review. The heavy side cover-up method.
Yeah.
You cover, and he wasn't heavy, right? You cover. I'm covering n.
Yeah.
What's the 0 of n? 0. Plug in 0. 0 minus 2. Negative 2. 2 over negative 2. Got it. So your turn. What's the next coefficient?
1. It's 1. You plug in 2. You plug in 2. You get 1.
Yes.
Cover. Plug in 2. 2 over 2 is 1. Yeah?
What is wrong?
So we start to plug in.
Reverse it, makes it easier.
Like a whisper. Better. Negative 1/3. Plus 1 over 3 minus 2 is 1, right? Okay. Plus, plug in 4, negative 1/4. Plus, 1 over 4 minus 2 is 1/2. Oh yeah, everything's canceling, right? Pause, be patient. Ooh, life lesson. Be patient. Where am I at? Plug in 5? Negative 1/5 plus 1/3, right? Ooh! What do you see?
1/3.
Hey! Let's keep going.
That's gonna take a
Plus, negative 1 over 9, that's 6, right? Plus 1/4. So the 1/3's gonna cancel, the 1/4's gonna cancel. What else do you think's gonna cancel?
Everything else besides the 1. Oh, not the 1, 1/2. And the 1.
Besides the 1 and the 1/2.
What? That's all that's.
Interesting.
Who am I gonna take the limit of?
That function.
Pause and consider. If I was to go to the nth term, and I was to get negative 1 over n plus 1 over n minus 2. You gotta think about how this happened, right? It stayed, it stayed, it stayed. This guy canceled with the previous, right? So who stays as we start canceling in an expression for an nth term? The negative one stays. The second one cancels. So the positive one cancels with the previous negative one, so this negative piece would be in the nth term. This would cancel with a previous term, and this would remain. So I need to go to infinity, so I'm taking the limit as n goes to infinity of that guy, which is, of course, 0, and 1 plus 1/2 is 3/2. The question, a little bit tricky?
Yeah.
But partial fractions all of a sudden made it into a telescoping series. Pause. Oh yeah. Pause and look. How could you have figured out that it was convergent to begin with? Without seeing it was a telescoping series?
Oh, the bottom wins.
Bottom wins, so we know nothing.
I'm just looking at it.
Remember that test is for divergence only. I heard integral test. Could we integrate?
Oh, G.
Would we probably use partial fractions if we were to integrate?
No, that's how I was saying.
Oh yeah, P series.
Nope.
No.
We cannot, wait, pause. We cannot just say P series. What could we say though?
Oh, because we have separation P series tests.
No, P series test we can eventually use. Listen to Jason. The direct comparison test. We could have compared it to a P series, seeing if that P series was hopefully bigger, because it would have less of a denominator. Yeah, that would make sense. We could have compared it to 1 over n squared. Maybe 2 over n squared would be easier. Just ignoring the minus 2n. Wait a minute, minus 2n. So if we ignored that, wouldn't we would have had a lesser function that converged? That wouldn't have been good. Can you think of a comparison one that would have worked? Because if you just did 2 over n squared, which you want to do P series to, it's smaller because it has a bigger denominator, since this one would subtract 2n. We could do something like plus 2n, but then we still have to do the integral test. Why not just do that to begin with? We could try 2 over n. Bigger, but it diverges, so it tells us nothing.
It's a fraction.
Yes, how about that integral test for the telescoping series then? Woo! Pause! Even if you did the integral test, wouldn't it just tell you that it converges?
Yeah.
So would you have been able to find the sum?
No.
Or evaluate?
No.
Got it. But would you have used partial fractions, and maybe that would have given you a hint? I hope so. So, telescoping series. Boop, 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 boop. Let's make this an endeavor card. Let me see if I already have one in. I think I do. Let me go find real quick. I'm already in BC. No, I'm not. Class notes, endeavor. The last one that we've had so far is the direct comparison test, right?
Misty, are you making another card?
Oh, it's not up there? Sorry. Is it frozen? Let it go. I'm looking at our endeavors. Our direct comparison test was our last one, which was number
17.
Come on, I had
Misty, can I get my jacket from my locker? Thank you.
There we go. Kiddos, this is what I want in the endeavor. I'll go ahead and go back and put a nice yellow box around it, but that's what I want on the endeavor. The one thing that maybe we should change. I think I want to put it. It's not always be so that it depends on the series itself. How can we reword this, guys, in a way that works? I used a sub n up here. I don't really like that either.
As a function.
Wait, why don't you like B sub n?
Well, the problem is b sub n in this one was canceling out. I wasn't taking the limit of it. I was taking the limit of b sub n plus 1. So it depends on the problem as to whether actual b sub n is what I want to take the limit to infinity of.
cancel.
I could do like the remaining n. The remaining nth term, and just put that in general. The remaining term of the nth term, remaining
Just be another one.
Yeah. You know what approaches the finite number. Not portion of the end term. The remaining portion of the nth term. The remaining portion, that's gonna be awkward when I try to copy this. We'll do that. The remaining portion of the nth term approaches a finite number as n approaches infinity. We'll put it that way. All right, let me go ahead and try to get a better picture then since we updated that. Zoop, zoop. Zoop, zoop. Zoop, zoop. How much did I steal? Just this part, right? Okay. So, highlighted box for endeavor number 18, right here, for the telescoping series. Let me go ahead and grab my snipper if my computer doesn't freeze on me like it's doing right now. Do you see how long this takes? My life is ticking away. All right, so.
Your computer has the most problems with this whole thing.
Has what?
I don't know of any other teacher who has more problems with their computer.
Oh, it's so frustrating.
And the irony of
And I use mine, isn't that sad?
Yeah, you use it the most.
I know.
Yours is the most problems.
And I ask for help and I just don't ever get it. Anyway,
I'm sorry.
that's okay. It's not your guys' fault. Here we go.
Yeah, Windows 10 is actually crap.
Other technological teachers got help, but
The thing is because of.
they also didn't use school computers, so
No, the thing is.
maybe they're trying to tell me not to use their computers. I don't know. You guys got it?
Yep.
Okay, go team. Kiddos, we're not done with the section. There's one more test. Here we go. I just said we're not done. I don't understand. Okay.
I wanted more education.
Oh wait, now we have to put it on a whole new page.
Once again, it's okay. Just trying to make you guys a little more self-aware. The majority of us are horrible at multitasking. So let's shush and focus and get the notes, then we can have fun.
Isn't there no game where we're multitasking?
Katrina, is that?
I wasn't sassy.
Me? I'm not. He just makes sassy to me.
I love the one thing that you guys have to all take away from BC is like becoming more sassy.
You've been with us for 3 years.
It's not me rubbing off. We'll say it's Katrina rubbing off.
See what I'm
You ready to go? Corey rubbing off? Yeah. Noah rubbing off?
We love Noah though.
Noah could rub off on you. Like, I'm much rather have like no
The person that was remaining, the one that was like, they said it was the,
If I could select it.
not the negative one, but the other one. I'm sure. Why is that, why when we
Yeah, but who'd you have to provide?
we said that it was
Station.
the negative one over it, even though that one was the one that was crossing out.
Straight up mail version.
Okay, wait, I heard you wrong. When we were going through and crossing out, what would cross out first as we got to a new term? The negative 1 over n hadn't been realized yet. It gets realized later on. The 1 over n plus 2 had already been realized, so that 1 over n plus 2 canceled out first. The negative 1 over n needed more terms to cancel out. So if you notice the negative 1 over n,
But the 1/3 cancel, were the 1/4, and the 1/3 was the.
yeah, but check it. On an nth term, which would be this guy, think of when we first got to cancel out. We first got to cancel out here.
Yeah.
So when we wrote this term, which we could call this the nth term being the first, second, third. In the third term, this piece would cancel and this piece would remain. Does that make sense?
What's remaining of the first?
Yeah, because the nth term, we're stopping there. We're not looking to the future. And so this ends up canceling out eventually, but it needs like 2 more terms to be realized. So this is like an ending point, which we're going to push to infinity, but this ending point, he will cancel out with something prior or something previous. This guy needs more terms to be able to cancel. Does that make sense? That. So this is called the comparison test section. That's because there are two of them. They're both comparison tests. So there's direct comparison tests where we need to have one always be lower than the other, or at least we could, separate off a few terms and then it's always lower or equal to, or higher or equal to. Limit comparison says, we don't need that whole less than greater than thing. Oh, we don't need that whole smaller, bigger thing. That makes this one a bit more, right? A bit more convenient, hence the note at the bottom. This is easier to apply than the direct comparison. However, just like the direct comparison one, you can choose series to compare to that don't tell you anything. Now, in the Endeavor card itself, which is Endeavor number 19, in the Endeavor card, you guys see what this test can show. You're not seeing the we know nothings. Ethan, why aren't we ready? So what you see is what the test can show, can prove, can do. You're not seeing the we know nothings, even though there are a couple. Who can tell a we know nothing from what is written in A, B, and C?
This is equal to 0 is the summation of b sub k divergent.
Exactly. If the limit equals 0 and I have a divergent, I know nothing. Or, if L equals infinity and you're convergent, then we know nothing.
Wait, yeah. Why does it matter which one you choose? Because if a sub k converges, then b sub k converges.
Well, we haven't actually talked about which one you're actually choosing yet, so hold on. Looking at A, B, and C, you should be able to tell which one we're choosing and which one we're dealing with. Which one are we trying to figure out? Which one's the problem given to us? Yeah, the conclusions. These are the guys we're trying to figure out what they are, right? So B sub k is the chosen. We're dividing by the chosen. Just because that way we can think of, well, hold on, this has to do with that efficiency thing. This has to do with that faster or slower thing. Because think about it, if I'm taking the limit as n goes to infinity or k goes to infinity, either way, if a sub k over b sub k, and if L equals 0, then who's stronger? The bottom or the given, right? If the bottom's stronger, can't I kind of think about that as bigger, in a sense? Well, if the bottom is stronger and I'm comparing with that bottom and it's bigger, I need that bigger to, wait, pause, this ties the two comparison tests together. If the limit equals 0, I want to figure out this guy, I'm dividing by that guy. If the limit is 0, the bottom wins. If the bottom wins, think stronger, I need the stronger to converge and squeeze in. If the stronger diverges, well, I don't know what the weaker one's doing. Is he following? Maybe. Is he stuck? Maybe. I don't know. Not stuck, but stabilizing. If the limit is infinity, who wins? So think of the bottom as being weaker or being smaller, in a sense. Doesn't mean every single term is smaller, but it's smaller in the sense of magnitude. What do I need him to do to tell me anything? Push out. So the infinity, I need the bottom to be divergent, or else I know nothing. I need, for when L equals 0, I need the bottom to converge. Okay? This is more analytic. What I mean by that is it's more algebraic. It's not so much like you have to make sure every term is less or every term is greater, all this like experimentation. It's not that. What it is, oh hey, what happens when I take the ratio? Can I simply, easily, possibly find the limit? Using your L'Hopital skills and other things like that, degree tests, etc. So you're going to be having to go back and actually do some solving with the limits to figure out 0 or infinity. But kind of like the direct comparison test, if we can think ahead and say, oh, it tells me nothing, well, let's stop, let's backtrack, and let's try something else. Yeah? Okay. You guys like a quick note about the AP, guys?
Yeah.
Logs? LNs, logs, either way, logarithms? This is a good test for them. Here we go. Let's play. Determine if the series converges or diverges. Pause! Why don't we just do the integral test? We can do something like, I don't know, make this guy like a perfect square, or maybe choose him, and then maybe do a u prime, and then, it's messy, right? And we still have to figure out the whole positive continuous decreasing thing. Why not p-series? No, way too much stuff going on. Why not direct comparison? Ew, do you really want to think of someone who's always less than or always greater than? No.
Does the Wait, did you say, which ones did you say didn't work?
I said integral test, it looks not fun.
Yeah.
I said P-series test, because it's n to a power, well, there's too much extra stuff, so I can't use P-series. Then I said, well, direct comparison, let's compare it to maybe 2 over n or 1 over n, but then we have to think about smaller, bigger. So instead, we're getting the hang of this. Let's go ahead and think about what would happen if we were taking 2n plus 1 all over n squared plus 2n plus 1 all over 2 over n. Now pause, aren't taking a limit as n goes to infinity or say goes to infinity or whatever, right? Pause, pause. Does the limit comparison test say go to infinity?
Yeah.
Okay, since it says go to infinity, in essence, what is the degree of this function? 1 over n, right? Or 2 over n, right?
Yeah.
In essence, I have a linear divided by a quadratic. In a sense, I have a rational function with a linear in the bottom, right?
Yeah.
Now, what's so snazzy about this test is check it. You're like, wait, I don't get it. Well, pause. Isn't this guy a lot easier to figure out than that guy?
Mm-hmm.
And pause, we should know who this is. P-series, P equals 1. This guy diverges. Struggle. This guy diverges. Pause. If we're dividing by a fraction, aren't we just multiplying by the... Okay, so I could rewrite this to be n over 2, right? What ends up happening?
N squared on top.
I have an n squared on top and an n squared on bottom, true? What's my limit now that I have an n squared over an n squared? 2 over 2, because this guy's going to multiply. So I'm going to have a 2n squared over a 2n squared. Forget the rest, they're lower in magnitude. The limit's 1. Pause. Limit comparison test. If L is greater than 0. I love getting a limit that's a constant. Because check out the test. If the limit's a constant, what one does, the other does. I don't even care the whole 0 infinity thing. Forget that. What one does, the other does. Right? So it says both converge or both diverge. So hold on, pause. Let's think about this. I was trying to show you a strategy as to what I did. Trouble. Trying to show you a strategy as to what I did, but now let's go ahead and talk about how to actually write this all out. Yeah? So first of all, guys, it'd be great if we could just compare to the infinite series of 2 over n, right? Since, isn't this the limit of a sub n over b sub n, aka times the reciprocal of b sub n? Cool. Since the limit equals 1, and, what am I going to say? You guys should go pick it up.
And
Yeah, approaches. Not approaches. It approaches 0, we know nothing. Don't do that.
the series.
A
series.
Oh. Converges, oh,
I don't need a
diverges,
comma there, I apologize, my Americans.
and
Diverges by,
by the P-series test,
Uh-huh.
we know that the summation of the first one,
I'm gonna put in parentheses, P equals 1, just a quick reminder. Then,
we know that the summation of the first one
exactly.
diverges.
What one does, the other does. Right? Okay, how do you?
Where did you get 2 over n? Like how did you?
I looked at the original, and I said, hey, in essence, like degree-wise, who is this guy?
Bless your soul.
And this guy is, in essence, like a 1 over n as far as its magnitude.
You just simplified it.
So if I think about going to infinity, and I think about the strongest guy at the top and the strongest guy at the bottom. And then I simplify.
Okay.
Does that kind of make sense?
Yeah, that makes sense.
I'm only doing that because as I go to infinity, these become negligible. Doesn't mean they're not there, they are very much there, but
But and does that always work or does it?
usually. That's just our first example. That's just our first example. Okay, so number 2, is this something that we might have seen with the direct comparison test? think about why we might not use the direct comparison test.
Oh, like why when it's equals to constant, there's both diverge or converge?
It's okay, we just need to learn our test.
Yeah, I don't know that.
It's the test.
Okay.
Yeah. But you can think of the limit. When the limit is a constant, the degrees are tied, so their magnitudes are equivalent. Kind of like with the efficiency, the faster, slower, we would say they're changing at the same rate.
Okay.
And so then what one's doing, the other will follow for sure. Think of it that way.
Oh.
Yeah. It's not very precise, it's definitely not approved by any means, but explanation. Number 2. Why not direct comparison? Why not just compare it to 1 over 2 to the n like we did yesterday? Because 1 over 2 to the n is going to be smaller because this denominator is smaller, this is bigger. So my converging smaller will not tell me anything about the bigger. So forget that. Instead think, let's compare. Anybody have an idea?
1 over 2 to the n?
Yeah. Let's compare to 1 over 2 to the n. We like him, we want to use him. Direct comparison won't tell us anything. So let's just take a limit and say, sweet. Since I'm just going for it. I'm just going for it, thinking it's going to show me something. Wait, isn't it the same thing as multiplying by the reciprocal? Yeah. Let me just kind of get that down.
Whoa.
Are the degrees going to be tight?
Yeah.
Yes.
Let's go.
See how it's more analytic though? We have more algebra to do. We have to think about dividing by a fraction, multiplying by a reciprocal, doing some math, taking a limit. There's definitely a lot more process to it as far as solving and simplifying, etc. But otherwise it's like, oh sweet, the limit's 1. Ha-ha! And what can I say about the guy that I chose?
Geometric series.
Cos. It is a geometric series, so use that test. And what can I say about this guy?
And since R is
1.
Converges.
R is 1. It is not greater than 1.
R is equal to 1/2, which you can say is in between negative 1 to 1. For R is equal to 1/2, don't worry, that's common knowledge for the AP graders. Then, my original series. So, can you guys tell that the nicest application of this is when the limit equals a number? You don't have to stress, just who cares? Who's the other guy what is going on of the guy that I'm comparing to? Oh sweet, just steal it. So when does it get tricky?
Oh, yeah. Oh my.
Well, it's like 1 of 1. It is greater than 1.
So what they're seeing right now, guys, is I think the guys in the front are trying to do the divergence test. They're looking really quickly and saying, if I was just to take a limit and then goes to infinity, Ln of n is not as strong as the extra times n down here. So bottom wins, limit equals 0, we know nothing. But they're also trying to think about what we should compare to. So comparing to, we have a couple different options. One is, we can think of, okay, in essence, if we just ignore the Ln altogether, we could think of n over n squared, 1 over n. We could compare to 1 over n, which is divergent. Another way of looking at it is, well, Ln of n, let's go ahead and round him up, and rounding him up, that'd be, okay, let's make him n squared over n squared is 1. Well, I'm not sure that's good. The limit over 1 isn't going to change anything. So let's try the 1 over n. Let's try just ignoring the Ln. Some of you might want to be thinking ahead. Since limit as n goes to infinity, keep this guy in the normal orientation, do what to the comparison one? Flip it. N over 1. Pause. Who wins? Top, because it's n squared times somebody extra. Right? Oh, it's not a constant. So pause. Pause. Who wins? Guy on top, original guy, or guy on bottom if it's going to infinity? Top wins, right? Which means my comparison one is smaller. If smaller diverges,
the bigger series.
bigger diverges as well. Or memorize your endeavor card really well and say, hey, whenever the limit is infinity, if I have a divergent, I'm good.
We just pushed out.
So B is like
But it's push up.
is always a smaller one. They will
Whenever the limit is infinity, the division, my actual is going to be greater than my comparison, aka my comparison is smaller, aka I need it to diverge. If my smaller was convergent, I know nothing. So since the limit equals infinity, and the sum from n equals 1 to infinity of 1 over n diverges by
P series.
P series. Can't put series, that doesn't make sense. P series. P is equal to 1. Then my original yucky thing that I definitely did not want to do an integral thing to, and it wasn't near as nice to do everything else to it. Diverges as well by limit comparison. Okay, pause. Could you try to get really good at the logic that basically leads us to this conclusion whenever we have a limit equaling infinity, taking the given over the comparison? The limit's infinity, the comparison is smaller, I need the smaller to diverge. Yes, you could get really good at that. Could you just get really good at memorizing the test? Yes. Which way does your brain work better with? Do that. Memorize the test, or grapple tonight with understanding the theory behind it. Try.
Okay, so I understand how to get diverged, like the whole thing diverges from the comparison. Why do you say that? You said 1 over n is smaller? Or less?
Well, the limit's infinity, so the bottom has to be small. Top wins.
So if the top wins,
Infinity. If the bottom wins, 0.
but
For a limit to infinity. Degree test.
okay, so I'm just confused why how come
Horizontal asymptotes. When we were doing degree tests, we would ask, are they tied? Does the top win or does the bottom win?
I get that. I'm just confused how you get to the same thing that both diverges.
Okay. Let's go back to the test. Number 1, you could just memorize it. True. Condition C. Number 2, you can say, whenever I'm taking a limit of the given over the comparison, whenever that limit is infinity, top wins. If top wins, bottom loses. If bottom loses, his magnitude is smaller. So I am saying smaller not as in every single term is less than. I am saying smaller as in magnitude loses to help you remember. If bottom loses, think smaller, smaller must diverge in order for us to know anything.
Smaller must diverge?
If smaller converges, I know nothing. I need smaller to diverge for me to make a conclusion. If smaller converges, test fails. Try something
Oh,
else.
so you took
If smaller diverges, then I can make a conclusion.
so you test 1 over n by itself, make sure it's divergent.
Like we do with all of our comparisons. Remember I said that this test only shows the ones that work? And remember there are 2 cases where we know nothing. So if the smaller, because of the limit, converges, I know nothing. If the smaller converges with the limit being 0, I know nothing. I apologize. If the smaller diverges with the limit
Yeah,
is
because
0.
I didn't see where you test the lesser one, that's all.
Oh, right here.
Yeah.
P series. Okay, so, you guys have some more examples to do. We didn't get to finish all of our, oh, look, we're missing one. Good. Homework, OT, section 9.4.
You were like,
Due tomorrow.
Yeah.
Okay.
Why did you pick 1
I love the Ellen event over
Ellen event would have been harder to do. And number 2, who's stronger between the 2? That guy, so I ignored the lesser guy. But that was nice.
Yeah, I mean,
Right now.
Katrina, I'm not saying it always works, but check it out and see which one's good. So I was trying to, how we try to strongest terms. I chose the strongest.
Steve, I think my brain just exploded.
You suggested how with your.
My brain just blew.
Did it? Why did you do that? Too much everything coming together?
They used to know.
Jay Reeves.